generative AI, image recognition, self-driving cars. We explain all of them with a single word. Learning? But when a machine learns, what is actually happening? The answer isn't hidden in AI, it's hidden in physics. Today, I'll help you completely understand how a neural network learns, using nothing but high school physics. Welcome to Minima Lab. Let's break it down. A neural network is just a giant function. You feed in an input, say, the pixels of an image, and out comes an output, say, the probability that this is a cat. Inside this function are millions, even trillions of little knobs. We call them parameters or weights. Learning sounds complicated, but at its core it's just this: turning those knobs, little by little, until the right answer comes out. So what does turning them correctly mean? This is where physics enters. First, we put a number on how wrong the AI's prediction is. We call this the loss. A perfect answer and it's zero. A miss and it grows. Here's the key idea. Think of that loss as potential energy. The horizontal axis is the value of the knobs. The vertical axis is the loss. Now the problem of learning can be rephrased as a single question. Where is the lowest point in this valley? In nature, a ball always rolls downhill. Water flows to the lowest place. Energy seeks its minimum. AI learning is doing exactly the same thing. So how does the ball know which way is down? The answer is the slope, what physics calls force, and math calls the gradient. The steeper the slope, the stronger the pull. The flatter it gets, the weaker the force. AI does this with calculation. It measures the slope where it stands and takes one step in the opposite direction. Measure again, step again, repeated millions of times. This algorithm of stepping down the valley, one step at a time, that is gradient descent. The size of each step is called the learning rate. Too big, and you leap right over the valley. Too small, and you never arrive. It's exactly the same dilemma as the time step in a physics simulation. But there's the same trap we find in nature. The ball can get stuck, not at the true bottom, but in a shallow dip along the way. We call this a local minimum. In physics terms, think of supercooling or a metastable state. It isn't truly stable, yet it gets frozen in place. So real AI deliberately adds a little randomness. That's the idea of thermal fluctuation, and varies how it moves to escape this trap. Let's pull it together. AI learning is adjusting the knobs. The size of the mistake is the loss, the potential energy. To learn is to descend the energy valley. And what sets the direction is the slope, the force, the gradient. The magical sounding idea that a machine learns turns out to be the same physics as a ball rolling down a valley. Next time, we'll look at the magic that computes this single step for trillions of knobs in an instant. Backpropagation through the same lens of physics. If understanding AI through physics clicked for you, subscribe. And in the description, I'll leave a free tool so you can try today's math yourself. See you at the next valley.